Yeah. So let me introduce myself. I am Amit Kapila. I am working in databases, Oracle and Postgres from more than 2 decades. As of now, I am working in PostgreSQL from past more than 13 years, and I am a major contributor and committer in PostgreSQL community. So, and I work at Fujitsu as a senior director. So, to start with, I would like to start with how the PostgreSQL open source product has evolved over years, like especially for the large enterprises. So with Postgres 6 in 1997, first time the open source inherits the Postgres project, which was being developed at University of California, Berkeley, since 1986. From there on, each year, Postgres mostly has one major release. Starting with PostgreSQL 10, we started with some of the enterprise features. Like in Postgres 9.0, we introduced streaming replication, which makes it possible to create the high availability kind of situations where first node goes down, then the physical standby can take up. Then with 9.1, we have improved that by providing synchronous replication, where there is a guarantee that when the operation has performed on the primary, it will be replicated to the standby. Then we have introduced the concept of foreign tables and unlocked tables. With 9.2, we came up with index-only scans, where any scan doesn't need to go to the table. It can just directly fetch the data from the index, which will be quite faster. And then popular data type JSON data type has been introduced in 9.2. In 9.3, we have introduced two updates to the foreign data wrapper and introduced materialized views. In 9.4, JSON has been improved. An improved version of JSON data type, JSON-B, has been introduced. With 9.5, row-level security, BRIN indexes have been introduced. And 9.6, we have first time introduced the parallelism in PostgreSQL, which enables it for some sort of OLAP workloads by introducing parallel sequential scans and some sort of parallel joins also. Then we also introduced multiple standby servers in synchronous replication in 9.6. So somebody could form a quorum kind of thing where 2 or 3 standbys must get the data. Then Postgres 10 was a major release where we have introduced some very big features like declarative partitioning, where previously partitioning in Postgres for large data was cumbersome for users to declare or define the partition tables. And then also we have introduced logical replication, which eventually will become the base for active replication in PostgreSQL. And also it helps in moving the partial data to a standby node or a subscriber node. Then with 11, we introduced SQL stored procedures and improved partitioning. SQL stored procedures is a feature which primarily targets migration from other well-known databases to PostgreSQL. Then again, we have with 12, we have improved the partitioning performance and introduced table access methods. With table access methods, anybody could write a new storage engine for PostgreSQL with much more ease as compared to earlier. Like if some of you have worked with MySQL or a kind of database where they can have multiple kind of storage engines built for their specific needs, like row kind of or column store, or append only kind of tables. All such kind of schemes could be privately built using these table access methods. Then in 13, we have improved the B tree index by deduplication and introduced parallel vacuum for indexes and incremental sorting. And 14, we improved the reads by improving our snapshot scalability. We have improved the logical replication by allowing replication for in progress transactions, which reduces their lag for very large transactions. Then we again improved the B tree by reducing the bloat in the B tree and parallel foreign table scans via Postgres FDW. Then with 15, we introduced the merge command, which was, a very well-known feature from Oracle, which where you can combine multiple statements into one statement: insert, update, delete. Then we started introduced a major enhancement, which is shared memory stats. Earlier, the stats were per backend. So by collecting the stats in the shared memory, which improves the performance and also allows Postgres to add more monitoring capabilities. Previously, because each backend or each process needs to send stats to one process, we couldn't add many more statistics, or the monitoring capabilities were not as enhanced. But after this, our capabilities will increase with each release. Then again, we have enhanced logical replication by introducing row and column level filtering, where more partial data could be transferred to the other node with these features. Then for the backups, we introduce server-side compression, which makes the backups faster. So for larger tables, or larger data, this kind of technology will allow the backups to be taken faster and also shorter. With Postgres 16, we allowed parallel apply of large transactions, which, for customers of logical replication or active-active, this is a big feature for reducing their apply lag. And also we allowed the logical replication for standby, which I will explain a bit in after a few minutes. Then we also enhanced our JSON syntax with SQL JSON standard compliance. This also helps the other applications or which are using the JSON to migrate to Postgres. Then we improve the relation extension, or like bulk copy load kind of workloads, where bulk writes could be done faster via the faster relation extension mechanism. And then we also provided the load balancing via our client driver libpq. So this helps users to distribute the connections to various servers. Postgres 17 is expected to come in this Q3, around September, but I will cover some of the features in my slides. So today's agenda for me is to cover the basic or the key features of Postgres 16, which released in last September or October, and then talk about what's upcoming in Postgres 17, which is going to come in September, and what we can see beyond that. So let's start with some of the key enhancements of Postgres 16 in the logical replication area. So one of the major drawbacks till Postgres 16 was that we were not able to set up two nodes where each node can communicate across each other. For example, if there is the same table on two nodes and both the nodes operations are performed, it would create a bidirectional loop. The data is moving between the nodes, same data, which doesn't allow active-active sort of replication. So with this feature, like origin-based filtering, which users can specify by while creating the subscription, such kind of setups become possible. Basically, this can be used to set up n-way logical replication that will prevent loops in the system. Then we allowed the logical decoding from standby. This can be used for workload distribution by allowing subscribers to stand by when primary is busy. So this is kind of workload distribution and help the distributed workloads in a reasonably good way. But for this, you need to set up the WAL level as logical on both primary and standby. Then we also improved the apply process on the subscriber side to perform the operations with table owner's privilege rather than the super user or the subscription owner privilege. This is sort of a security enhancement where users doesn't want anyone else but the table owners to perform the rights on the table. Then we also allowed non-super users to create the subscription. Previous to this, only super users were allowed to create the subscription. So guys, you can ask me anything anywhere in between. I don't know how many people you have used the Postgres or these setups, and you may not be familiar to any of these things, but if you have any questions that because these are latest developments which have been done on existing Postgres. So if you have any questions in between, also feel free to ask. Don't think that I'm here to just present what's going on. If you have any basic question, I will try my best to explain you in the best possible way.
Yeah, if you have a question, just raise your hand. I'll get you the mic. Yeah.
Hello. Yeah, my question is a little generic, but I wanted to know how this PostgreSQL is performing on ARM when compared to the Intel processor, and is it performing better on ARM or is it performing better on Intel? And the second thing is, if it's not performing better on ARM, what are the specific areas that are the ones that are not performing?
Yeah. So if I understand correctly, the question is that how, although it is not related to latest developments, but it's a generic question, that how Postgres performs on Intel architecture versus ARM architecture.
Right.
So I think it mostly any performance thing depends on your workload. Given the same workload, personally, I haven't measured any such data, but Postgres is well known, tuned for Intel architectures, and it's being worked on. It is quite possible that for ARM architecture, there could be some specific improvements which could be done. And I have seen in past in the Postgres community that people do propose the enhancement specific to ARM architecture. So some of the things would have been done, some of the things would not have been done. But if you ask me as a general Postgres product, do we do any specific tuning or making our architecture feature work better on ARM? No, that's not by default anything. We generally test on Intel power. So I think, but if you see or notice anyone that on ARM, this is not performing good and there is a way to improve that, we are most welcome. But I don't have any ready-made data or answer to you.
Okay. Thank you.
Thank you.
Anything else that is related to the slides we can take in the between? Hi. So the origin-based filtering that you're talking about while subscribing, is it a part of any kind of sharding that's going to be supported in Postgres as a first-class citizen, for which the origin-based would definitely help? Is it a part of a bigger theme that's going to be built in Postgres?
Yeah. So the question is that how this origin-based filtering would eventually be used in sharding or any kind of those things. The idea is that as of now, this active setup can only be done via the users by the commands provided by Postgres. We don't have any standard APIs or tools where you can say add my node or set up my cluster. But eventually we may, or Postgres may provide such easier way to set up the active application where you can use it as a sharded or partitioned stuff. As of now, there is nothing. You have to do it by yourself. But if you want to really build those APIs, now it is possible by using this base feature. So let me move with next few slides, and we can again take up. So we, as part of our journal improvement, we are moving towards making most of the Postgres, or as much as possible, Postgres commands to not require the super user privilege. So this is one of those features where we enhanced it so that for creating the subscriptions, now you don't need to be a super user, but you need to have granted a PG create subscription role, and the non-super users are required to specify a password for authentication. Though the super users can set password required equal to false for non-super users that own the subscription. So next I will specify like what I have told in the beginning, that with Postgres 16 we started allowing large transactions to be applied in parallel on the subscriber side. Users can use max parallel apply workers per subscription to tune how many parallel workers for large transactions could be used. It depends on how many large transactions you are expecting in your system to go in parallel. We have observed about 25 to 40% workload for performance improvement for bulk workloads or various kind of workloads during apply. Then we also allowed to use the indexes other than primary key and replica identity on the subscriber while applying the changes. Prior to this, when replica identity full on the publisher is set, it can lead to a full table scan on the subscriber side while it applies those changes, if the primary key or replica identity indexes are not present. But with this release, even if your normal B-tree index, which is not a partial index and it must have at least one column reference, that kind of indexes could also be used to apply the changes, especially update and delete, where index scan is required. Here, the performance improvement is proportional to the amount of data in the table you already have. Next, I will speak about some of the enhancements or performance improvements in the storage engine of Postgres. So the first one is faster relation extension. This provides significant, like 3x performance for 16 clients for concurrent copy into a single relation. The idea was previously we were doing a lot of work under one extension lock, which we have reduced to something very minimal. So concurrent copy on a single relation now could be much more performant, as I have told, 3x in some kind of workloads after this enhancement. Then there is a popular enhancement for updates, which we call as hot, heap only tuples, like where any update doesn't need to update the index. So we further enhance that feature so that only hot updates are required if only Brin index columns are updated. Prior to this, if any, even if Brin column index is updated, all the corresponding indexes or all the indexes for that relation will also get updated. So in short, now Brin updates will reduce the write amplification for updates. So this does not apply to attributes referenced in the index predicates. An update on such an attribute always disables the hot. Then we have introduced a PG stat IO view to show the detailed IO statistics. Prior to this, like many a times our systems get hogged by IO due to write operations, due to bulk loads, due to vacuum, due to checkpoint, Postgres itself. Various kind of workloads could load your IO subsystem, but it was a very limited capabilities, or not very precise capabilities were there in Postgres for users to know how they can see where the actual bottleneck is. With this view, we have tried to address this to some extent. For example, now with this view, you can see like what kind of IO operations are going on, like whether it is read, write, extends, hits, evictions, or reuses, or fsync. Which kind of operation is being performed by which kind of process. So that helps to, sometimes tune your database. For example, if there are large number of fsyncs being done by the client backends, this could indicate misconfiguration of shared buffers or misconfiguration of checkpointer. So as of now, there is no differentiate between data which is loaded from directly from the disk or from the IO buffers. But yes, this is really a very useful enhancement in the Postgres to monitor your IO. I think I can take up some questions if you have.
My question is with respect to earlier where you have the non-super user. Yeah, can you hear me now?
Yeah.
For the non-super user, so when the non-super user is given the permission to create a subscription, and once the if by mistakenly or something like we revoke the permission, will the subscription will be still doing the replication setup, or like what will happen like from the security point of view? Or
Okay.
like we delete the non-super user.
Okay, so the question is that the owner which has created the subscription, if that user itself has been removed from the system, or its privileges like page create subscription has been revoked, what will happen? I think there could be various kind of impacts. For example, I don't think we are going to drop the subscription if that user is dropped. So one kind of problem could come that if, like when we apply the changes, if user has not specified some parameter, we will use the subscription owner to apply the changes. So now if that user has revoked the privileges, maybe your apply process, apply changes can also fail.
No, but like, will the subscription in the replication, will it be still working? Like
yeah, subscription will still be working. The subscription won't be removed.
We are not removing the subscription. I'm talking about the user. If the permission is revoked, so
yeah. So if permission from the say, for example, let's see this. So if you revoke this permission of PG create subscription from the user, what's going to happen? The only thing subscription will be still working because you have already created it, right?
Yeah.
So so simple answer is that subscription will be working, but there could be some impacts, as I have told you. By the way, how many of you have migrated to PostgreSQL by now, or 16 by now, or on which release you have? Which Postgres version you are using?
Our product is still using PG10.
PG10, oh. But is there any reason why you have not migrated yet, or is it just like upgrade it takes time to upgrade the databases? Yeah, but I think you are missing a lot of exciting features.
Yeah, we definitely are. We do need to prioritize that, but
They're migrating from 11 to 15. Yeah, Postgres 15.
Oh, this is the one of the most recent. So which application you are?
It's like we have multiple banking applications.
Oh, banking applications. Very good to know. So is anybody moved to Postgres 16 yet?
We only move with the latest versions of the enterprise. Normally take the rebase this activity from the open source to the 16.
Yeah, but in your, my question is, did your product or your application has moved to PostgreSQL 16?
No, we are not that level.
Yeah, you are into software development.
Yeah. So, Amit, I have one question for this. So, the logical replication today doesn't support. The logical replication today doesn't support like I have a database like MySQL or. So, what I meant to say is the logical replication can it support instead of Postgres to Postgres, it can have Postgres to some other database. So, in between something DBGM will be there. Some of the like S3 or something. You put it the data and that.
Yeah, see, native Postgres doesn't provides output plugins which user can use to do it. I know there are few companies who have recently started in US like PeerDB who are moving the database from Postgres to other databases, say Snowflake or others. But that kind of capability, Postgres provides you a plugin. You can use that to write your own capability. So, okay, let's move to this so that we keep making some progress. But it's nice that if more and more people participate in it, it will actually improve our knowledge more. So then we also came up with a new option for vacuum or analyze to increase the number of buffers it could use. So this allows the user to control the size of shared buffers these operations can use. The higher the value, the operation, your analyze or the vacuum speed could be improved because now more number of shared buffers are available, but at the cost of concurrent buffer evictions by other operations. So this parameter or this option needs to be used very carefully. Like in down, when you know that your other workloads are not very heavy and there is a bloat in your system or your queries needs analyze operation, then it is good to use this so that you can complete those operations faster when the workload is not at its peak. Then next I will like to highlight some of the key SQL enhancements. For example, we have improved journal support for text collations. Like we have introduced some sort of rules where user can specify how the sorting will behave. For example, with such a rule, you can say that G will come after A but before B, which is the normal, not our ASCII sorting. So you can add the new options are added to create collation, create database, create DB, and in a DB to set such rules. Then, as I have mentioned, one of the key features for 16 was to improve the SQL JSON standard by making their standard constructs like JSON array. This constructs a JSON array from either a series of value expression parameters or from the results of the query expression. And similar to that, there is a JSON array aggregate which behaves quite similarly, but as an aggregate function. So it only takes one value expression parameter. Then we also can construct a JSON object of all the key value pairs given or an empty object if none are given. Similar to JSON array aggregate, we have introduced JSON object aggregate, which behaves like JSON object, but as an aggregate function. So it can take one key expression and one value expression parameter. I'll share some example with you. For example, you can see that here for a JSON array, if we have given key value pairs, it would construct from that the JSON array. Similarly, JSON array aggregate works on single parameters. So all these single parameters became array. So this is basically more or less functionality which is conforming with the SQL standards. So if you are using some other database and migrate to Postgres for JSON, this will help you in that. Then other kind of JSON standards we have introduced is like by on the expression, you can apply these constructs to know whether it is a JSON value, whether it is a JSON array, JSON object, or JSON scalar. For example, if you provide applied these constructs on these values, you can easily come to know whether it is your expression is a JSON value or JSON array or JSON object. Then we also enhanced our parallelism further by allowing parallel hash full joins. Basically, this helps in some kind of OLAP workloads where you have full hash joins, and now those will use the parallelism to make it faster, which means more number of processes can work on that data set and can get you the results faster. Similarly, now when these kind of functions like string aggregate and array aggregate are used in a query, such query could be using the parallel plan. Prior to this, such an aggregate functions won't allow to use the parallel plans. So yeah, this is another sort of enhancement in the parallelism. So with this kind of enhancements, you can broadly say that we have slightly improved the parallelism in Postgres 16, and some of your OLAP workloads could improve with such enhancements. So the full detailed list of features could be found in the link I have provided. So there are more than 180 or so detailed features which have introduced in this time. I wanted to tell you about this. So this is the release which we have released last year. Now I will cover the future of Postgres, like what we are currently developing, which you will see in the next release or in the releases to come. But before that, if you have any question, feel free to ask.
Can you talk a little bit about the libpq load balancing that you mentioned in the first?
Okay. So basically, I haven't covered here, but the primary thing there we allowed is to provide multiple hosts via your connect parameter string. For example, now you can provide multiple hosts or that kind of thing in your connection string. And if the first host is not available, it can go to the second host, or it can distribute the workloads in some way. Like there are some parameters, if I remember correctly, like random or something, where the queries will be distributed to the host. So this is kind of new thing I think I should have covered, but we can get those in the docs.
Follow up on that only. Is it supported for Java or is it a C++ library only?
It is not language specific. It is via the libpq driver. Like if you are for Java, you must be maybe using JDBC. So JDBC either might already have or not have, or they might do after this. That I'm not sure. That driver is there, I think open source, but it is not maintained by community. So I'm not 100% sure. But once it is there in the libpq, I think they can support similar thing, or maybe they are already supporting it. I don't know.
So can you throw some light on the parallel hash join strategy and other strategies that are available?
So
can you throw some light on the parallel hash full join strategy?
See, I don't know very details of the things, but you can see from here, like whenever the earlier this hash full join is used, at that time the parallelism is not used. What does that mean is that now each of the nodes can perform the partial joins on a subset of the data. Okay, so So now this on this simple, so if this relation is there, say simple, like you are joining both these simple relations. So on this relation now you are going to do the parallel scan, like parallelly the processes are going to scan it and build the parallel hash table. Earlier it was being done by a single process.
So where is the improvement, like in terms of?
Improvement is in the parallel scan of this. Like basically earlier only one process was scanning your relation. Now multiple processes are scanning. They say you have 10 blocks. Earlier only one process will first scan one block, put in the key in the hash table. But now one process can scan 2 blocks of the table, another 2. So the work is distributed that way. So if 5 processes are scanning 10 things, your time is reduced by 1/5, something like that. But very good question. So are your workloads some OLAP specific or something, or it's a general curiosity question?
No, I'm actually still, learning about databases.
You are learning Postgres.
Not Postgres, but in general, I'm learning about databases and data side of things. So
yeah, but it is a really good question. So I thought maybe you already have some workloads.
Just one more question. Hello. Can you elaborate on that active-active configuration of Postgres? Like, what are the boundaries of it and what you can achieve?
Active configuration. So the question is, can you elaborate more on active support? Yeah. So let me come to the beginning only. So whereas one can build their own active replication based on Postgres, but still we are lacking some of the features which which users may need to take care by themselves. The foremost in that is conflict management. Like in the active, it is quite possible. For example, you have updated the row here. On the second table, that row now doesn't exist. So your update will go. So conflict has happened. So the primary thing for the active is to handle such kind of conflicts by automatically. The system should happen. At this stage, Postgres doesn't have the capability to detect the conflicts or handle them. They will just simply log it. And if the conflict happens, users need to either manually resolve those, or we provide a command, sort of skip command, which you can skip that command and continue the replication. So I would say that there are few kind of features like conflict management, DDL replication, which are lacking in Postgres. But if users can manage by themselves, then they can create the active replication by their own by using the commands provided in Postgres. So I will actually have to come in the later part of my presentation here. So these are some set of improvements which we need to do to make Postgres by default provide active. Today you can build on top of it by yourself. Yeah. Okay, so let's move to PostgreSQL 17, which is going to come. This is still under development, so some of the features I'm going to explain could be reverted back or wouldn't be included in the final release, but I am going to tell you the features which are already committed and there is some chance of those being seen for Postgres 17. The first one is to allow the upgrade of logical replication nodes. What does that mean is that if your publisher subscriber setup is already present, and if you upgrade your Postgres instance, say she was using 10, now there was already a logical replication. If she upgrade to Postgres 11, she has to again set up all the publisher subscribers again. It won't automatically work. And she might also need to copy some of the data again to make this replication setup work as it is. Starting with PostgreSQL 17, users will be able to upgrade their logical replication setup as it is when, say, they migrate from 17 to 18. So this is one of the key features developed for PostgreSQL 17. So I think this will majorly help the users of logical replication or sort of active-active replication setup in Postgres. Then another key feature is incremental backups. As of now, one of the major lacking thing for Postgres was for very large databases. Users always need to take complete backup or set the streaming archive replication to get the backups. But with incremental backups, users can get only the incremental changes in the backup. You know, your backup sizes for large data will reduce to a very small size and it will become much faster. I'm not telling this is any innovative thing or not, but this was the catch up for Postgres, which other databases or outside tools provides from quite some time. So with PostgreSQL 17, we are also going to provide it. And PG-based backup can be used to take an incremental backup by specifying minus incremental option with giving the path of the previous data which has been backup in that. In the resulting backup, only changed columns are changed blocks are copied. A new process known as WAL summarizer has been introduced to collect this information of the change blocks. Then on the client side, a tool PG combined backup is used to reconstruct a full backup from an incremental backup and earlier backups. Then we optimize the vacuum of relations with no indexes. So we reduce the amount of WAL by reducing certain number of steps when we remove such data from the table which doesn't have indexes. Then we introduce a login event trigger, which allows to fire some actions when users log in. So for example, you can, using this feature, you can set up your system such that you don't allow certain specific users in some particular time frame of the day. So this was also a feature which was being requested for a number of years, and Postgres 17 will have it. Then we have a numerous number of speedups for serial portion of parallel aggregates, like sum, average, variance, etc. So we have reduced the number of pallocks and mem copy during their deserialization. So the parallel workloads have using these functions should see the speed up. Next, we added temporal, primary, and unique key constraints. What does that mean is that the earlier indexes only like B tree can have this primary key. But now for columns like date range, valid at, you can also use the primary key and unique constraints with the clause without overlaps by using the without overlaps, which are backed by gist indexes. For example, you can see here, we have created a primary key constraint on ID and the date range using without overlaps. If I inserted these values and try to repeat the same key, like 1, there is no conflict because this range is different. Similarly, when I change this integer, but this range is different, there is no error. But when the key is same and the range also overlaps, see this overlaps with this and this. So that creates a conflict key violates this primary key. So this is a new concept introduced in Postgres 17. Then an internal enhancement for PG constraint, not null constraints have been done. Now, not null constraints are being stored in a PG constraint system table like any other constraints. It may not provide any significant development opportunities for app developers, but this makes it consistent with other constraints like all the check constraints. Then we also enhanced our monitoring via PG stat vacuum progress. There you can now monitor your index vacuuming. For example, how many indexes have to be vacuumed and how many are already done. Then sadly, we have removed a parameter known as old snapshot threshold. This feature used to define a time threshold for snapshot during which the old row versions will not be deleted. After that time, old row versions will be deleted. And some of you who are familiar with Oracle would have known this snapshot too old error would have come. But we have removed this feature because of the instability and lot of design issues have been found. So later releases may see this feature again, but as of Postgres 17, we have removed it. If any of the users were using it, they need to now cope with it. Then we also introduced PG wait events, a system view where user can see what exactly your waits are going on. Earlier in the PG stat activity, you can know that what process is waiting, but what exactly the description of the wait is, you can find out via this new system view. All the checkpointer related stats now could be found in PG stat checkpointer. Previously, some of this information was stored in PG stat BG writer, which is now scaled down, and the required information is now found in one place. You can see that with this release and previous release, we are continuously now enhancing the PostgreSQL's monitoring and statistics capability. And this is a complete story started with 15, where we have improved our statistics storage system to shared stat storage system. I think now going forward with each release, you will see that more and more monitoring capabilities are being added. So these are the features which have been already committed. Next, I will talk the features which are under development, or you will see in later releases, not in 17 or maybe in 17, like synchronization of replication slots to allow failover. Basically, if your publisher and subscriber is there and there is some physical standby, as of now, if your primary or publisher goes down, your subscriber cannot continue. But with this feature, we provide a high availability sort of scenarios where your active can also work even if one of the active nodes goes down. Then DDL replication. Right now in logical replication, we don't replicate DDLs. This is another enhancement which is waiting for years. Replication of sequences, conflict detection and resolution, and node management APIs, as my friend has asked. Like this will provide the inbuilt capability for users to just set up active with high ease. Then we are also working on a major features to optimize the SLRU access for sub-transactions and multi-set data. Dilip is working on it for PostgreSQL 17, and we are hoping to see it. This will improve workloads with large number of sub-transactions or high rate of multi-set generation due to row locking. I think in the next talk by Dilip, you will see how or the details this optimization work. The next talk is specifically for this enhancement. Then like we are also working on reducing the number of commands that need super user privilege. SQL JSON improvements to make it more standard compliant, transparent column encryption, asynchronous IO. This is one of the features which is going to improve the IO subsystem of the Postgres in a major way. Index prefetch, this will improve the index access performance, and we are hoping to see this feature either in 17 or 18. A lot of work has been put into this. And then journal all the heap and everything prefetching or asynchronous IO is being implemented. Then we also intend to enhance our table AM APIs based on, the new storage engines users are writing. Then AM check for gist and gin indexes. AM check, those of you who don't know, is a utility or tool to check the correctness of your indexes, whether your indexes are corrupted or not. To some extent or to a good extent, that gives you the answer. So those enhancements are also going on. Then better scalability, improvements in vacuum technology, partitioning technology, statistics monitoring, and also TD, transparent data encryption. This is one of the features being discussed for many years, which some government agencies or the standard agencies wanted to achieve for this standard compliance. Then to reduce the bloat and reduce the vacuum problems, we also intend to work on 64-bit XIDs that can avoid freezing and reduce the need of auto vacuum. Then parallelism, where we allow parallel safe init plans, parallelize correlated subqueries, and stuff like this. WAL size reduction for smaller headers in WAL, toast improvements, and we also work on our CI and build system improvements. That's it from my side.
Guys, can we please have a round of applause for this great session? Okay, so we can open up for Q&A. Any questions regarding the session, we can take it up.
Hi, regarding parallelism, I just want to understand, can we control the parallelism? See, I am from a SQL Server background. Okay, so
Can
I'm
you
just learning.
stand up and ask?
Yeah, I'm from SQL Server background.
Okay.
So majorly I work with SQL Server and started with Postgres RDS from 1 year back. So just want to understand parallelism. See, in SQL Server, you can control parallelism either the query level or the instance level.
Yeah, we have some parameters to control the parallelism at the instance level, like max parallel workers, yeah, or max parallel workers per gather.
Got it. Okay. So
at the node level, you can control.
Okay.
But for particular queries, I think you cannot control. It is at the system level.
Okay, because in SQL Server, right, you can make a query to learn parallelly or sequentially. So you can do that. The particular workload, can we make it to work sequentially whenever required?
Yeah, say we at the table level we specify some parameters like parallel workers. If your table doesn't want to participate in parallelism and you set that parameter, I think the parallelism won't be invoked for that table. But for a particular query that this has to be used, I think users have to always set max parallel workers per gather equal to 0 or some number.
Okay.
But otherwise, in the query, you cannot provide anything.
Okay. We have something called as, like, I'm just trying to correlate. Okay. Is audible now? Okay. So I'm trying to correlate. So we have something called as cost of threshold. Okay, so where you put a particular value, if a query meets that particular value, right, parallelism will turn on to that query. So we have something like that in Postgres.
Not exactly, but we have some things like costing parameters, like max a transfer size of I don't remember the name, but how much cost it will take for one row to transfer from worker to leader. If you reduce that parameter, probably more. So it is something similar, like where your parallelism could be achieved more if you reduce that cost.
Thank you.
Parallel tuple cost, like tuple movement and like this.
Yeah. Hi, Amit. Hi. Yeah, Amit, my question is a bit simple. I'm a newcomer in Postgres. So question is regarding, you mentioned about incremental backup.
Yeah.
And you also, I think you said it reads from the WAL, right? You go through the WAL and do that backup. Is it possible to get consistency also through this?
Consistency means?
In the sense that whatever you don't complete the transaction till the backup also has an update of it.
I think the main idea of the backup is to take all the change blocks from one node to another node.
Okay.
So at the time of backup, whatever your changes are, those will be incrementally backed up. Like all the change things will be.
Okay. It's post that. Okay. After.
Yeah.
Okay. So it's not during the transaction when the backup happens.
No, it's not doing any transaction consistency or that kind of
all right. Okay. Yeah.
Things.
Yeah. Other question again was you talked about encryption.
Yeah. Dilip, you want to add anything?
No, I think I got the answer.
No, I think got the answer.
I got it.
Is it correct, right?
Yes.
We don't do any transaction consistency management in that.
The other question, you talked about encryption, which is coming up. Right? TDE of,
yes.
I'm
not telling it is coming up, but it's being worked upon from many years in Postgres.
Is it similar to those column level encryption which they talk about?
No, it's a different, like it's basically for the physical data which is being stored in WAL or table.
Okay.
Column is a sort of logical kind of entity, right?
Yes. That
it is on the physical layer.
Yeah, that too is a compliance requirement. That's what I was asking.
So for you also TD is a compliance requirement?
No. I mean, I have seen organizations, at least the banking organizations, would like to have the column level encryption.
Oh, column level.
Yes, which I think most of the other databases do provide that. But okay, thank you.
Thank you. So which organization you work with?
I work with a company called Rocket Software. It is
software.
Rocket Software. It's actually a partner of IBM mainframe. So we work on tools which deals with DB2 for DB2 and all that. It's a private equity firm, Bain Capital. They actually support that. Yeah.
Thank you. So I think for me it's very good to know like companies like you are also started to use. Have you?
No, we are not. I am exploring that to apply it in our products. I'm trying to learn more about it.
Okay. I think feel free to reach out to me if you have any questions.
Sure. Thank you.
Hi. Hello. Hi. So I have a question related to incremental backups. So, so does that mean that the parts which are like driving the incremental backup facility, can it translate to incremental or like CDC type behavior so that like batch processing can be done on certain tables such that only incremental data is being processed upon?
I don't think we have a facility to, basically you want a logical replication kind of thing where you want the increments of a particular tables to only come.
Correct.
That kind of facility enhancement at this stage is not there.
Correct. So right now we have workloads which are like CDC oriented. And currently we use Snowflake primarily for our entire thing, and Snowflake has this capability to do streams. There are certain workloads which we totally see can be run on systems like Postgres, because like Snowflake is like way too expensive for such transactions. But then the buck stops at that there is no CDC facility out of the box, and we don't want to yet put additional tooling on it. So yeah, that's where my question comes from.
So, but why don't you directly use the CDC capability? You want to move the data to PostgreSQL.
Yeah, that's one thing. And then there are like certain additional batch processing we want to do on top of the data that's sitting in Postgres.
Oh, with this facility, at least incremental backups, as far as I understand, it's not there, but maybe there are other ways to achieve it. If you want to discuss, maybe we can discuss after this.
Fine, thank you.
Any more questions?
Hey, hi. So I saw like there's a good amount of work going on in IO subsystems. So I was actually curious if there's any work done, like started on atomic writes. I think atomic writes. So I think MySQL MySQL has started work on that. So I actually met the developer who is working on that, like during.
So you mean to say atomic writes does that mean without WAL support you are going to write it, or you mean that we don't need checkpointer or any such things? 8K page should be directly written to this.
Yeah. So it should be directly written to the disk, and then kernel guarantees that if it's once committed, it will be committed.
Yeah, actually, Postgres at this stage mostly relies on IO subsystem to perform it. So we don't have any such guarantees that 8K writes will be atomic.
And like not in Postgres.
No, in future it could be, but we are yet not reach that stage. Or maybe based on the AIO capability, we'll see how the things goes. There is another thing called direct IO, which is another feature being worked on. At this stage, nobody has proposed anything, but I am sure using this, it could be built if other systems are building.
Yeah, that's nice. Thank you.
Thank you. Nice question.
Hi, Amit. This is Adarsh. So my question is regarding index prefetch. So how does it work internally? Like, does it spawn a new parallel worker or?
No, it will just invoke the asynchronous API of OS, which will actually fetch the data in the kernel buffers, and as soon as we need the data, we will get it easily rather than reading it from the disk.
I have one more question. So this transaction ID wraparound problem was there for so long.
Yeah.
So now we are moving to 64-bit transaction ID. So
we are not moving to it, but yeah, there is a lot of discussion and work being discussed on that area.
So we can expect it sometime soon?
No. But eventually, see, some of the things, I am no one to say whether that will happen in next 1 year, 2 year, or 5 years. But I can just tell you, yeah, there is a discussion. Postgres community is aware. Many companies need it, and they are actively working on it. The real way to make it faster is that you also start working on it, because it's an open source, right? You can also work on it, but it's a quite challenging problem. It's not that simple. Otherwise, it would have been done by now.
Thank you. Thank you.
Thank you.
Okay, one last question.
It's related to the incremental backup. So since can we having the existing backup strategy, can we now we implement the incremental backup? Can we do the PITR, point in time restore?
Yep. Basically, I think point in time restore, I am not sure whether that capability is built into it, but we have a tool, PG combined backup, which reconstruct a full backup from an incremental backup, and earlier backups it depend on. And also it has the WAL, as far as I know, which you use to restore the things.
Yeah.
But PITR, I don't know, man. I'm not
we
100%.
do use WAL to restore the PITR, but like with the help of like PG based backup, like with the new incremental backup, can we do that? Just like in SQL, we have differential, we add it.
Sorry, man, I don't have clear answer. Dilip, you have any answer for it?
I think whatever you can do with the normal full base backup, the same capability incremental backup will also have. But instead of taking a completely new backup, you can take a small part of the backup and you can merge and finally make a complete full backup. So and capability of like PITR and all is not changed. It's same. Like with full backup also, you can do PITR in your WAL, and the same thing you can do with incremental backup also after merging to the full backup. Yeah.
Okay, before we wrap up, can we please get the goodie, just a token of appreciation from our end?
To whom?
For you.
For me? Yes. Okay, I think you can. Thank you.
Okay, thank you so much, Amit.